Hey everybody, we're on to section 10.3 here. This is talking about concurrency control with locking methods. Again, locking methods are the most common way of dealing with or managing concurrency in a database. So we're going to focus on locking methods. We're going to skip over timestamping and optimistic methods. You can take a look at them in the book. They're honestly just one page each. So they're not worth really spending a whole lot of time on here. And then we'll jump back into transaction isolation and database recovery management to wrap up this chapter. But again, the idea with locks here, right? Our lock says, I have access to the data here, you don't, right? Because we want to avoid our lost updates, our reading uncommitted data, and, the third one, all right, this is what I get for erasing things. Inconsistent retrievals. So we want to lock and say, hey, I'm the only one who's going to touch this data. If you want access to it, you have to wait. And usually we say this is pessimistic locking. We're just going to assume that no one else should touch the data because there will probably be a conflict. So preemptively, I'm going to go lock the data because I don't know if anyone else might have a conflict on it. So generally that's what we do. And this is all done by the lock manager, which is part of the concurrency control, which is awesome. So a couple different levels of locks, right? So you have this granularity here. Granularity. So we start at a very large lock up here, right? And we say this one is the database. Wow, that's a B. The database lock. If you have a database lock, no one else can do anything at all in the entire database. So this one is usually pretty frowned upon. That's pretty sad. We don't like those, right? Because no one can do anything anywhere. The next level, right, and imagine you have different tables in here to make that pretty picture. The next level is a table level lock. You say no one can touch the entire table until I'm done. And again, this one's generally kind of frowned upon because, no one can touch anything in the entire table is relatively large, and we don't really like doing those ones either. The next level, or the most common level here, is going to be a smaller chunk. This is called a page level lock. So a page lock says, hey, I'm going to take an entire page from disk and lock that entire section. So what happens in a database, right? It stores big chunks of data out into the disk somewhere. And we have a little bit of control over where it stores these things, but generally each pages of a disk is some fixed size, like, hey, it might be 16 kilobytes. And when we deal with writing and reading from disk, we're going to read an entire page at a time. There's all sorts of database theory about why this is good. Instead of saying, hey, let me just find one particular row here and just read like 15 bytes out, I'm going to read this entire page here and deal with things at page level. So generally you get like an entire chunk of a database table at this point. You'll get a bunch of rows that fit into this page. And page locks are real common. It's a smaller section than the table. So it's generally easy to use, and it's very natural for the database to be like, okay, I've read this entire chunk here. No one else can touch it till I'm done. When I'm done, I'll write that chunk back when I'm done. So pages are dealing, again, with how much data that we're reading of that fixed size, and we lock them. A smaller bit than that is a row level lock, right? This is row level. Now, row levels are great. We say, hey, no one can touch this row of data because I'm updating it. So it's finer detail than the page, right? But the problem with the row lock is that there's a lot of overhead because every row has to get locked and unlocked, right? So there's going to be a lot more locking that has to happen. Databases tend to be pretty good at this sort of thing because obviously that's what they do. And there's this really cool process where we'll start with row locks and then we can escalate automatically to a page lock if we see, hey, there's more than one lock being requested at this given page. And kind of protect everything that's happening and making sure that entire page level chunk is safe here. And you can also get just a single field level lock, but we almost never do those because just the overhead is crazy to manage, hey, this individual field one at a time that we've touched. Okay, so that's like the granularity of locks. And then we have different lock types, different types of locks. A basic lock is a binary lock. And that just means it is locked or unlocked. Locked or unlocked. There's only the two states. Right? Either it is or it is not locked. There's no confusion here. Either you've locked this or you've not. So that's generally our default easy lock state here. It's just a on or off. There's also an idea of a shared lock or an exclusive lock. So we can have a shared lock or exclusive lock. And the idea with a exclusive lock, right, is that only one transaction can have it. One transaction at a time can do it. A shared lock is where you're going to have multiple transactions here, right? Transaction 1, transaction 2, transaction 3, all sharing the lock. Generally, they're sharing some sort of read access, right? Generally, shares are for reads. If we're all reading the data, there's no need to lock it because we know read and read aren't going to have any sort of conflicts. It's only when something is updating that data that we need to deal with it. So we need to be a little bit careful on when we're dealing with our exclusive locks and shared blocks. Okay. And then looking at this idea of locking data in a transaction. If with that transaction we talked about, we had to say we were going to update the quantity of our product, and then we're going to insert an invoice and insert a line item, and then we're going to update customer. Right? If we were to do these things, we might say, okay, in my transaction, right, this is all one transaction, I'm going to lock that product row. So we lock the product row. Then we go insert our data, and we say, hey, I want to lock that customer row. Well, if something happened in between where, hey, maybe the customer was paying a bill and we were going to go update their balance, this might already be locked. So when we attempt to lock, we're stuck. And in that process of saying, hey, we want to, update this customer's bill, we go and lock that customer's table, and then maybe it needs to go update something else. We could end up where two locks are waiting on each other to unlock something. Right? We call that a deadlock. So a deadlock is bad, it's an unhappy state, right? Where two locks are waiting. Two locks are waiting for the other. I can't spell, friends. This is, it's actually really hard to write on a whiteboard or even a screen here. So hopefully, if you appreciate the difficulty of writing on things, but handwriting's never been my good thing here. So anyway, dealing with deadlocks is tricky. So one of the things that we can do is having a two-phase lock approach. So in a two-phase lock approach, we look at our transaction and we say, okay, here's all the things you need to do. This one, this one, this one, this one. Let me go lock, let me go lock, let me go lock, let me go lock everything ahead of time. Then I'll do my updates, and then I'll unlock, 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 and unlock to make sure that everything is ready for me to go, rather than saying, oh, okay, let me lock this table, do an update, and then, hey, can I lock this one? Oops, no, I got stuck. So the two-phase helps avoid some of that deadlocking here because it's a little bit more careful about it. But deadlocks, they still can happen. So what we need to do when we get into a deadlock state is we usually have to kill one of the transactions and let it roll back. So generally, if there's a deadlock, you pick one, right? If there's two things waiting, there's 1 and 2, you just kill one of them, let it roll back, let one finish, and then we retry transaction 2. Right? And it should be fine, right? It's not ideal because it kind of slowed things down, but it's not the worst process in the world. So generally, we have 3 different approaches when it comes to dealing with deadlocks, right? So we can try and prevent them. So to prevent deadlocks, right, we make sure that if you're about to lock something, right, then your whole transaction just gets aborted and rolled back to prevent the deadlock from ever happening. So this is like a proactive rollback. As soon as we see that it starts to happen, we just roll it back here. When you want to lock something and we think that a deadlock might happen, we just stop you. We say try again later. That's prevention. You could detect deadlocks here, and that idea is we wait to see if there's a deadlock, and then we go pick one and kill it. Right, so that is reactive. Right, so reactively we'll roll one back and then retry. Right, so roll back, retry. Roll back, retry. The last one here is avoidance. And avoidance is sort of that two-phase approach here. So we can avoid deadlocks with that two-phase approach. So we're making sure that we can get everything locked all at once. Then we can do our transaction and then unlock everything. So it increases the amount of time that it takes, though, because we have to lock, then we can start things. So this one is, a little bit more time intensive. So it kind of depends on what we're dealing with our database to see which one of these is going to be better. And sometimes it's a mix of all of them. So that's the traditional approach that most databases will use. Again, dealing with concurrency control is locking. Timestamping is interesting. Optimistic methods are interesting, but again, we're not going to spend a whole lot of time getting into them. You can read the section. It's just a one-pager in the book there. And we're going to pick it up with transaction isolation and database recovery coming up next.